Today we're looking at learning target 9. We're still solving equations. Day 6 is determining if an equation has no solution, one solution, or many solutions. The book has some different vocab for this, so I want you to be aware of that as well. Many solutions would be called an identity. And this is just so that when you're seeing that vocab in your book, you know what it means. I'm not worried about you memorizing the vocab, but so that you can follow the directions on your assignment, no solution would be inconsistent. All right, so determine if the equation has 0, 1, or many solutions. That's all that we will be doing. Step 1, we're going to simplify each side of the equation if necessary. In this case, we've got some distributive property, so I'm going to go ahead and distribute. 4 times 3m is 12m. 4 times 4 is 16. Distributing on the right-hand side, 2 times 6m is 12m, and 2 times 8 is 16. Now, some of you at this point, looking at the equation, might have an idea of how many solutions it has, but let's go through the rest of the steps so that you can see exactly what happens when we solve an identity or an inconsistent equation. So the rest of the steps are our normal steps for solving an equation. We're on step 2, we're going to get our variables together. So in order to move a variable from one side of the equal sign to the other, I will cancel it. So I'm going to subtract 12m from both sides. What I'm going to do next is, on the left-hand side, I subtracted 12m to cancel my positive 12m. On the right-hand side, my 12m cancels with my negative 12m. I'm left with 16 equals 16. All right, well, my variable disappeared. I have no step 3. There's no variable left to solve for. So I don't have to use the golden rule. I don't have to repeat. So I'm on to step 6 right now. Answer the question. Determine if the equation has 0, 1, or many solutions. The way that we do that is, if the variables cancel like they did on this one, and we're left with an equation that is true, such as 16 equals 16, that is true, our original equation has many solutions. It actually has an infinite number of solutions. Any number that you substitute in for m will make that equation true. You can substitute 1/2, you can substitute negative 364.528. Any number will make our equation true. And just to demonstrate, I'm going to pick a random number and substitute it into check. I'm going to make it a little bit easy on myself, and instead of using a crazy fraction, I'm going to use 1/3. That's not too crazy of a fraction. And I chose it because I know that I'm not actually going to have to work with the fraction for too long. All right, so I did use parentheses around my fraction instead of the times sign, so I hope that's not too confusing for you to look at. But order of operations, we're going to work inside the parentheses first. So right here, I have multiplication. 3 times 1/3 means my 3's cancel, leaving me with 1. Same thing over here. Inside the parentheses, I am going to multiply. 6 times 1/3, or 6 divided by 3, remember that's what that bar means, is 2. Still inside the parentheses, 1 plus 4 is 5. Still inside the parentheses, 2 plus 8 is 10. On the left-hand side, 4 times 5 is 20, and 2 times 10 is 20. So my random fraction checked out. Any number you substitute for m will make that equation true. It has many solutions or infinite. All right, let's look at one more. Simplify each side of the equation. In this case, I do have some simplifying to do on the left-hand side. I've got 5x plus 2x. It's on the same side of the equal sign, so I will do what it tells me to do, and it tells me to add. Oops, sorry, let me back up because I have some simplifying over here too that I missed. All right, so we have like terms on the right-hand side as well. Negative 3x plus 10x. I'm going to do what it says, and that is 7x. Again, some of you might be able to figure out what's going on here, but we're going to follow step 2, get our variables together. So I'm going to cancel 7x by subtracting it. So So on the left-hand side, 7x minus 7x cancels, leaving me with a negative 3. Don't lose your negative sign. And on the right-hand side, 7x minus 7x cancels as well. Cancels to what? Well, what happens when you do 7 minus 7? If you have 7 x's and you take away all 7 x's, you have 0 left. So we did use the golden rule to get our variables together, but again, our variables canceled, so we're going to jump down to step 6 now and answer the question. Again, if the variables disappear and you're left with a statement that is true, you have many solutions, like 16 equals 16. If you are left with a statement that is false, like negative 3 equals 0, you have no solution or 0 solutions.